This video is going to walk you through the first 3 exercises of the Annuity exercises spreadsheet. I've already put my student ID and hit the start button in, so let's go ahead and just go to the first tab and get started. Now this first exercise is going to ask you to value an annuity, or the idea of getting a set cash flow for some set number of years, in this case $90 for 3 years, and we're going to value the annuity 3 different ways. We're going to do the Excel formula, just the math formula typed in, and then we're also going to explicitly value each cash flow and then add them up, discount them back to our present value. All right, so the first way we want to do this is actually with the math formula. So we just review our math a little bit here, and we need the present value of an annuity formula. So to get that, we're going to say that the present value of an annuity at time 0 is equal to the cash flow times 1 minus 1 plus r to the negative t, all divided by r. All right, that's our present value of an annuity formula. We're going to end up using it a lot throughout the course, so it's worth knowing now. At least be familiar with Wikipedia so you can look it up really quickly. All right, so now that we have that formula, we can actually type that into our Excel file. So let's go up over here into our math formula answer. And to type this in, I'm going to say equals my cash flow divided times, and here I'm going to set up my parentheses, 1 minus 1 plus r raised to the negative t, the number of periods is 3, close my parentheses, and then divide by r one more time. And there we see 231.94 is matched to our correct answer cell. All right, well that's, you need to know a formula to do it that way. It's the most straightforward and the most manipulable way you can do it. So really using the math directly is the most powerful. Sometimes though we can use an Excel formula to make it a little bit easier on ourselves. In this case, the PV function calculates the present value of an annuity. It'll also tell you exactly what to put into it. So the first thing you put into the present value of an annuity is the rate. So let's go over and get that 8%. N per is the number of periods, or the number of cash flows. In this case, we have 3 periods, 3 cash flows. And then finally, the payment, or the cash flow. Here we're getting $90. Close the parentheses, hit enter, and we almost got the right answer. Right? It says $231.94, but the number is negative. So Excel doesn't really have a good concept of knowing whether the cash flows are going away from you or towards you, or whether you're getting the cash or paying it. So in this case, to flip that sign for us, we just have to go back into the formula with F2, put a negative on our payment, and now we get our 231.94. So 2 different ways, either the present value function or the present value of an annuity formula will get us to the same answer. Our last way is going to be actually to build the model. So here I'm going to actually build that model fairly dynamically. We're going to start with year 1. And I want to build this model to work for any number of periods. So 3 is the number it's asking for us. Yours might say 7 or 8. So I'm going to go ahead and do it a number of different ways. So the first thing I'm going to do is set up my years. I'm going to say the year, the first one, it's the first one plus 1. And so now if I copy that down, and I'll go down a ways just so we have plenty of room, we'll go out to 20 periods. All right, so now we have 20 years of cash, 20 years in our model. Now we need to figure what the cash flows are. So here our cash flows are starting in year 1, and we want them to just go for these first 3 years. After that, we want them to stop. So in this case, I'm going to use an if function to do that. And I'm going to say if, and now my condition or the logical test here is to say, is the year less than or equal to the number of periods? Notice I'm being careful to lock the number of periods. If it's true that the year is less than or equal to 3, so 1, 2, or 3, then I want my cash flow. Again, I'm locking that cell reference. Otherwise, I want a 0. Now let's see if that works. So if I do Control-Shift down arrow and Control-D, I fill that formula down, and I see $90 for each of those first 3 years. All right, so that looks pretty good for me so far. Present value of $1. Here I know I can use my 1 divided by 1 plus r, lock the cell, raised to the number of periods. In this case, the number of periods is the year that I'm in. So I'm going to discount 1 year for a cash flow in period 1, 2 years for a cash flow in period 2. So that same formula I'll be able to copy down. I'll do that in 1 second. And to calculate the present value of the cash flows, we'll just multiply the cash flow times the present value. And we have that. So now I can take all of these cells. I'm going to copy them. Control Shift down arrow, up 1, Control D didn't work in that case, but I can use Control V to paste. And notice that I have the present value of all these cash flows down here in years 4, 5, 6, 7, 8, 9, etc. But there's no value over here in the present value because I'm not getting a cash flow then. So finally, we can check to see if my answer is right and do my sum up the entire model. And we see we get the same answer. Answer 1 is correct. And so again, if we go back up here, we can see the same 3 answers. And what's nice about this is if we were to change the number of periods, the model's still going to work, not just with 3, but with 5 or 10 or 15 periods, all the way up to 20 periods, the model's still going to calculate that correct answer. All right, so moving to exercise 2, we're still calculating the present value of an annuity. We're just changing when the cash flows happen. So in this case, the cash flows are going to start at time 0. That's all that's going to change. So let me go back and get my model. I'm going to copy those first couple rows, and we'll build from here. And the first thing we know that needs to change is the first year needs to change to 0. Because our first cash flow is now at time 0. Now we have the present value of $1. That adjusted properly, right? We're raising 1 divided by 1 plus r to the year. In this case, the year is 0, so it doesn't discount. $1 today is worth $1. So our discounting looks okay. Now we just want to make sure we can copy this thing down. And let's see what happens. So let's go down almost to the bottom. And now we see that we got all the way down to 18 cash flows in this case. That'll work. And let's see if we got the right answer. We sum, and we see that we overshot. So the first thing I want to say is, well, did we get it right or not? I think the correct answer should probably be 250.49. And the reason I think that's pretty close is we can actually go reference exercise 1. In exercise 1, the answer is 231.94, right? And the only difference between this problem and the next problem, exercise 2, is that you get the cash flows at the beginning of the year in problem 2 versus at the end of the year in this problem 1. And so if we get our cash flows sooner, you should get more, right? And so that's what we see in exercise 2. The 250 is bigger than the 230 that we saw in the last problem. But 321, well, that's just way too big, right? Because if we take $90 for 3 years, that's $270. So it certainly can't be more than 270. Now, if we look at our model, we can find the problem pretty quickly. What we see is that we now have 4 cash flows, not 3. So that means we need to change this formula here. And rather than being less than or equal to 3 periods, now we can just change that to less than 3 periods. That way it's only going to work for 0, 1, and 2. And when we get to 3, it no longer allows that cash flow. So we change that formula, paste it down, and now we see that our answer is correct. All right, so we used our old model, and we got the right answer. So now can we actually use a math formula to get us to that same place? And the answer is yes. In this case, what we assume in this annuity formula is that the first cash flow always occurs at time 1. All right, so if we want to move everything back 1 period, then we can assume the first cash flow starts at time 0. But to do that, we also have to change a few other things. So if this cash flow is going to start at time 0, that means that the present value now is going to be as of time -1. But that's not what we want. We want the present value at time 0. And the present value at time 0 is equal to the present value at times -1 times 1 plus r. So to get from -1 to 0, we have to move forward 1 year. It's just like going a future value of 1 year. So going from -1 to 0, we have to multiply by 1 plus r. So if we want to adjust our formula, let's go back to our Excel file. I'm going to come back here and take my math formula, move it to exercise 2 and paste it. It's not correct yet, but now we can come in, wrap the entire thing in parentheses. We got to be careful how we're multiplying things. So let's wrap it all in parentheses and then multiply it times 1 plus R. So here I need to use my mouse to go over here. And now we see that we got the correct value. So all we had to do was take that same present value of an annuity formula and move it forward 1 year in time. The last thing we can use is our Excel formula. So here we can use our PV. We're going to set up the same way with our rate, with our periods, with our negative cash flow. But now we're going to notice that there are 2 more arguments in the function that I didn't use before. Notice how both these arguments are in brackets. That means they're optional arguments. So the future value is how much is this thing worth when all the cash flows are done. In this case, we're going to keep it simple and just say 0. And then the last argument is the type. It's asking me, do I want the cash flows at the end of the period, which is the default and standard, or do I want them at the beginning of the period? That's how we change the problem. So here we want that beginning of the period, which is the 1. And so we hit enter, and we get our 250.49.